Hello and welcome to the Reigate College Further Maths video on scalar product. So the scalar product or dot product is an operation that we can perform on two vectors. And we're just given to start with, we're given a definition of it. So if I've got A dot B, that's why it's called the dot product, then if I've got two vectors, 1, 2, 3, dot 4, 0, -1. The dot product of them, there are two things we can say that it's equal to. It's going to be the I components multiplied together, the j components and the k components, and each of those added up. So we would have 4 plus 0 minus 3, which is equal to 1. So that's one definition of it. Another definition is that it's equal to the modulus of this first vector multiplied by the modulus of the second vector multiplied by the cos of the angle between the two vectors. Now, an angle between the two vectors will be the angle when both vectors point either towards or away from the point of intersection. So if I had two vectors like this, in order to find the angle between them, it wouldn't be that angle there. We would have to continue this vector on. Think of sliding this vector down here. That would be the angle between them in that case. So they either need to both point away or both point towards the point. We could also slide that one across. Now, some important points about the dot product. If A and B are perpendicular, then from this definition here, if this is 90 degrees, cos of 90 is 0. So this is a very important property of the dot product, that if they are perpendicular, the dot product is 0. The reason why this is equal to this is something that you can look up for yourself, but it is at the moment, we're just going to take it as that is true. Another thing that's true about the dot product is if two vectors are parallel, then the modulus of AB is equal to the modulus of A times the modulus of B, and in particular, A dot B will be mod A all squared. So let's do some examples and you will see what's happening here. So this says, first of all, find this dot product. So you simply multiply 1 by 3, and you get 3. And you multiply 2 by 4 and you get 8, and then that is going to be equal to 11, and that's the answer to find the dot product of those. Okay, here, given that A is that and B is equal to that, show that they're perpendicular. If they're perpendicular, A dot B will be equal to 0. So if we find the dot product of these two, we're going to have 1 times minus 3 plus 5 times minus 1 plus 2 times 4. Because this is a show that, we're going to be really quite clear about how we do this. Minus 3 minus 5 plus 8 equals 0. And so because this is 0, this implies the vectors are perpendicular. Okay, let's look at what happens with the I and j vectors. So if we look here at I dot j, well, these two vectors I and j are perpendicular, so if we find the dot product of them, that will be equal to 0. If we look at k dot k, that's going to be modulus of k, which is 1, times the modulus of k, which is 1, multiplied by cos of 0, which is also 1, so this is just equal to 1. And then here, we've got 4jk. Now, j dot k will be 0, because remember that I, j, and k are the unit vectors in the three directions of the axes, and they are all perpendicular to each other. So j dot k, that's going to be 4 times 0, which is 0, plus this is going to be 3 times 3 is 9. I dot I is going to be 1, So that is equal to 9. This is really just to show you why this particular fact here is true. If we think of finding the dot product of two vectors together, we only need to consider the components that have the same letter when we're doing it. So that's why when I did this example up here, we only needed to do 1 times 4 for the dot product. But that's really not something to worry about too much at this stage. You can come back to that later. All right, let's see what this dot product is used for. It's used for various different things. I'll take you through each one. So it's used to find the angle between two vectors and the angle between two lines. And to do that, we often end up rearranging it. So if you know that A dot B is equal to mod A mod B cos theta, then you can rearrange it to get that the cos theta is A dot B divided by mod A mod B. You can learn this formula here, or you can just learn this one and rearrange it when you need to. So let's have a look at how this works. It says find the angle between these two vectors. So if I've got two vectors here, to find the dot product, I'm going to say that the dot product of these two vectors, so if I call one of them A and the other one B, it's equal to mod A mod B, lost a modulus sign there, cos theta. So work out the left-hand side first. That's going to be, I dot product these together, I'm going to get 3 times 2 is 6. 6 multiplied by -1 is -6. 2 multiplied by 3 is 6. So that's what the dot product's equal to, but it's also equal to the modulus of this vector, and that's going to be the square root of 3 squared plus 6 squared plus 2 squared, multiplied by the modulus of this vector here, 2 squared plus 1 squared plus 3 squared, multiplied by cos of theta. So this gives you that cos theta is equal to 6, which is the left-hand side, divided by, this is going to be square root of 49 is 7, this is going to be 14 root 14. So if I do inverse cos here, I get that theta is 76.8 degrees. Notice that this came out to be a positive value. If it comes out to be a negative value, you would get an answer of between 90 and 180 degrees for that. And what that would be telling you is that if you've got two vectors like this, maybe the angle between them is actually 120 degrees. But if the question asks you for an acute angle, then you do need to find that angle there. That's where this modulus sign here comes in useful. So whatever you get for the cos, you actually find the modulus of that and do inverse cos to work out what's going on, to find the angle. Right, find the angle between these two lines. So remember that with lines, we've got a point on the line, and then we've got a direction vector. To find the angle between two lines, we find the angle between the two direction vectors. So this question comes down to finding the angle between this direction vector and this direction vector. So we are going to look at 3 minus 6, 2, which is the first direction vector, dot 8, 1, 4. And that's going to be equal to, when we find that dot product, the modulus of this vector, which is going to be 3 squared plus minus 6 squared plus 2 squared, which is 49, so that's 7. So it's going to be square root of 49. This is going to be 64, 65, square root of 81, cos theta. So from this, now we work out the dot product, 24, so 3 times 8 is 24, minus 6 plus 8, is equal to, let's see what we've got here, 7 times 9 cos theta. And rearranging that, I get that cos theta is equal to 26 over 63. And so then I'm going to work out inverse cos of 26 over 63 is equal to 65.6 degrees. So to find the angle between two lines, we find the angle between the two direction vectors. Right, the last use of it here is to find one vector that's perpendicular to two other vectors. This comes in very useful when you go on to do further vector work, in particular finding equations of planes. So if I've got two vectors like that, and I want to find a third vector that's perpendicular to both of them, so I can draw that going back that way. I want to find one vector that's perpendicular to two that I've got already. Then I can use the dot product to do this. So you want to let the vector that you need be x, y, z. So let the vector be x, y, z. So this vector here is x, y, z. Now, what do we know about x, y, z? We know that it's perpendicular to A and it's perpendicular to B. So if I do the dot product with A, that's going to be equal to 0. So that's dot product with A, I get minus 2x plus 5y minus 4z equals 0. If I do the dot product with B, that's also going to be equal to 0. So I get 4x minus 8y plus 5z equals 0. Now at the moment we've got two equations and three unknowns. The reason for that is that there are lots of different answers to this, because any multiple of this vector will be perpendicular to these two. So what we have to do is we have to fix one of x, y, and z. And in this case, we're going to fix z equal to 1. So let z equal 1. We could have let z be anything we like. Probably better not to choose 0, but we could let it be anything we like. We could have let y be anything we like, or x be anything we like. So what we're trying to do is fix one of the variables here. So if I do that, I let z be equal to 1, I then get the two equations, minus 2x plus 5y equals 4, taking that 4 over there, and 4x minus 8y equals minus 5. And if I solve these, I'm going to double this one and add this one on. I get that 2y is equal to 3. So y is 3 over 2. And substituting back in, I get that x is 7 over 4. So this gives me a vector that is going to be 7 over 4, 3 over 2, 1. And that vector is perpendicular to the two that we were given. It's always a good idea to check at the end, just in case you've stumbled across a value here that makes it not work. That can just occasionally happen. Don't choose z equals 0. Don't let any of the x, y, and z be 0. But it's worth just checking that this works. So you check this works by putting it back into these equations and checking that they work out. So that's how you find one vector that's perpendicular to two other vectors. There is another method for doing that, which you might cover in class. It's not actually on the syllabus, but it can be quite a useful shortcut.